Okay, so my students in Physics 4B class, Merced College, today it's in chapter 27. If you remember, we did about Kirchhoff's rules about circuit, and most of you sent me your results about the quiz, about the example that I gave you, which majority was very good correction, very good solution. Actually, I really liked your answers. So today we are going to talk about RC circuit. What is RC circuit? By the name, which it says RC, R means is resistance or resistor. So R means is resistor. Like what? Like light bulb. Like what? Like windshield wiper. Like any electronic pieces, any electronic, circuits that they need to keep the time, to control the time. We use RC circuit in keeping the time, in controlling the time. So R is resistor. What is resistor? It's consumer. Light bulb is consumer. Windshield wiper is consumer. Defibrillator is consumer. The flashlight that you have behind on your phone, actually, for camera, it is consumer. So these are all R. Your computer is consumer, which it's you have a lot of applications of RC circuit in your computer, in your desktop. I can tell you in all electronic pieces, electronic circuits, in majority of them we use RC circuits. So R is resistor and C is capacitor. Okay, so as you see, when we say RC circuit, that means is connection of resistor to a capacitor, and then how we need a potential, then we need to connect both of these to a battery. Therefore, guys, RC circuit is actually heart of time-keeping circuits. Do not forget this. So in any circuit, you need to control the time, that how much electric current you want to pass through the resistor at certain time, how much charge you want to have on capacitor at certain time, how much voltage you want to have across capacitor at the certain time. So you control everything by elapsing time. This is RC circuit. That's why it's RC circuit. Usually it's called heart of time-keeping circuits. So in anything that you see delay in working, like for example, windshield in your car, windshield wiper, you see it, you can adjust it. If you see on the gauge, you have lines like 2, then 4, then 6, then 8. Like if you put on 2, for example, let's say every 2 seconds it will work. If you put it on 4, for example, it will work every 4 seconds. So what do we have here? We control it. We need time. If we need time, you need RC circuits. Now, therefore, if let's say, if I say this is a capacitor, so it is C, okay? Then guys, if I say, sorry, so let's say this is a capacitor, okay? I connect this capacitor to a resistor, all right? Then I can make some circuits like this. So let me call this one switch S. So it's like key, it's like switch. And then here, this is positive, it's a battery. There you go. So let's call this one position A. So let's call this one position A, this one position B, and this is switch S. So far makes sense? And guys, let's call this one E epsilon, which epsilon usually it's V max. What does that mean? That mean is the voltage of power supply or battery. Okay. Some book they go by V max, some book they go by E or epsilon, big epsilon E. Now, what do we have here actually? So we see a battery, then we have a switch S, then we have a capacitor, then we have resistor. So RC circuits have two sections. One is called charging of capacitor. One it's called discharging of capacitor. One is called charging of capacitor. One is called discharging of capacitor. At the very beginning, so before we close switch S, before we move switch S to position A, this capacitor, I don't say 100%, but it doesn't have charge, but it has from the very 10 years, 20 years ago, from the day that it's made, it's already charged because it's tested in the manufacturing. So charge never becomes zero in the capacitor. You will see why. So this capacitor, let's say at the beginning, it's discharged. It doesn't have charge. Now, if we move switch S on the position of A, okay, therefore, what I am going to have, I am going to have actually, so section 1, it's, let's call it charging of capacitor. So we charge capacitor, ladies and gentlemen. Therefore, what I am going to have, I will say this, if switch S shifts to position A, what we are going to have if switch S shifts to position A, I am going to have this. This is a battery, correct, with E. Then here is position A, switch S is closed, correct. This is resistor. And here I have position B, which is just one wire. All right. And this is C. So if I shift switch S, so this is switch S, to position A, look at this picture. If I shift switch S to position A, in reality, I close it. If I close it, what I do at this time, I am connecting this battery, the maximum voltage, to a capacitor, to this capacitor. Then capacitor and resistor, they will have finally same voltage as the voltage of battery is. Okay. Now, what I am going to have, so I am charging capacitor, correct? Therefore, if I use Kirchhoff's rule, the second one, which it says total voltage in one closed circuit is 0. So this is my closed circuit, correct? So what I am going to have, so I'm going to start to go from this point, Let's go. What is this one? It's a battery. What is the battery actually? It is the second pole is positive, so it will be positive E or V max. Then let's go. Oh, what is this one? It is capacitor, correct? So it's capacitor. Capacitor here gets charged, so it eats energy. It's consumer, correct? So I am going to have plus voltage of capacitor, correct? And then plus voltage of what? Resistor, equal 0. Now, what I am going to have, E is epsilon is epsilon. This is voltage of capacitor. What is the voltage of capacitor, guys? We know that this equation Q is equal CV, capacitance times voltage, so this is delta, capacitance times voltage is total charge. Therefore, we can say voltage of capacitor, correct, is equal with Q over C. Therefore, but because voltage of capacitor is consumer, am I right? Capacitor is consumer, so it will be minus Q over C. So instead of VC, voltage of capacitor, I put Q over C. And also, as we know, resistor, which this is resistance, resistor is consumer, so we are going to have what? Minus RI equal 0. Correct? Now, so guys, as we know, so in the lecture, chapter 26, if you remember, I, what is I? It was delta Q over what? Delta T, correct? Or we said I can be equal with dq over dt. So far makes sense? So what is I? Change in current per time. Okay, when electric current, so this makes I actually battery. When electric current goes through capacitor, is charge on capacitor increases by time or decreases? Make sense? So when electric current flows inside this wire, when it reaches to this capacitor, it's caused to charge capacitor. Now, is this charge on capacitor increases by time or decreases? What is your answer? I will say increases. We increase charge. Why? Because electric current as time pass increases. So if electric current increases on the capacitor, therefore charge increases. So I mean, like for example, right now is 3, then after, for example, 1 second is 5, then after another 1 second is like 10, after another 1 second is like 18. So what I see, 5 minus 3 is 2, 10 minus 5 is 5, 18 minus 10 is 8. So Q here increases, correct? Therefore, guys, pay attention here. I is positive dq over what? dt. This is d. All right? So, what I am going to have at this time, I am going to substitute these things in this equation, Kirchhoff's rules. So, I can write E minus Q over C is Q over C minus R is R, okay? Instead of I can write dq over what? dt equals 0. Now, guys, what we got here actually, this is differential equation. This is differential equation. So if I solve it, and if I find Q versus time, which actually this is your job, I usually did this one last semester. It takes like maybe 20 minutes, 15 to 20 minutes. But it's your job, please solve this equation, differential equation, and find q, which it will be function of time, is equal with what? Okay. So you do it, work on it, and I'm going to write a final equation. That's what I am going to get. So after we did differential equation, we will receive this equation, guys. Watch it. Q as the function of time is equal with Q naught parenthesis 1 minus E. So this E, it's not charge of electron, it's natural log. E to the power of negative T over negative T over RL. Sorry, RC. Why did I tell you L? Because I was thinking about RL circuit. We have also RLC. RC. This is our major and main equation. Qt equal Q naught parenthesis 1 minus E to the power of negative T over RC. What is Qt? Qt is charge. These are very important. On capacitor. So here we see that charge is a function of time. Charge and capacitor at certain time. In other words, it's this. It's charge of capacitor when t second after switch S closed. Make sense? So, like, let's say we close this switch S, we start time. Like 1 second, 2 second, 3 second, 4 second. Okay, stop it, stop it. So that is your time. T equal 4 second. How much is charge on that capacitor after 4 second, for example? This is important. What is Q naught? It is initial charge on capacitor. I call it honestly Q max. So I will say Q naught, it's same as Q max. Okay. I like to say Q max actually. I like to say what? Q max. So let me put here, I think max is better. Okay? Initial charge on capacitor. What is Q max, guys? The maximum charge. We know this equation, Q is equal what? CV, right? So Q max will be C times what? V. What was the voltage, the maximum voltage of capacitor? It was same as the voltage of battery, correct? It was same as the voltage of battery. Now, if we work on this problem and if we use again this equation Q equals CV, we can find actually same equation for voltage across capacitor. Your equation will be this. Vt, so this is V, equal, let's write this one, V max, parenthesis 1 minus e to the negative t over what? RC. Keep it. What about electric current I? We will receive same equation. IT is also what? I max, parenthesis 1 minus e to the negative t over RC. So these three equations, let me write QT also, is Q max, parenthesis 1 minus e to the negative t over RC. And also we have Q max is CV max. We know this, correct? These are four important equations, let's say, that we use them in charging of capacitor. In charging of capacitor. Okay? Where did I go? Can't find my image actually. That's okay. Now, let me talk about time constant of RC circuit. Look guys, if you see in this equation, we do have RC, multiplication of resistance times capacitance. Multiplication of resistance times capacitance. Resistance times capacitance. This RC we showed by a quantity which it's called tau. So it's not big T, it's tau. Tau, like torque, we had it in chapter 12 in physics 4A. But this is not torque. We showed by tau. Okay, it's not torque, remember. It's called time constant of RC circuit. So this tau is called what? Time constant. Now, here it comes this thing that, guys, this is resistance. This is capacitance. So How can multiplication of resistance by capacitance becomes time? You know, in physics, if we want to write one equation, both side, left side, must have same unit as right side have. So if we call tau is time constant, so the unit is second, correct? Because the unit of time is second. So what about the unit of RC? Is it second? What is the unit? If it is second, then we can call it time constant. If it's not, it's not. So I want you to think about it, please, that how multiplication of RC. So, you know, the question is this, find unit of RC. In other words, why do we call it time constant? Is the unit of RC is second? I don't know. You can help me. What do you think? RC. Use equations that you know. Okay. Guys, we know by Ohm's law, V is equal what? Ri, am I right? So this is Ohm's law actually. Therefore, by this equation, can I say, because I need R, can I say R is voltage divided by current? Yes, keep it. Watch out. Now let's work on C. Let me change the color. Let's work on C. You know, very important equation actually, which I already told you in the class. Q is equal what? CV, first, middle, last. Resistance, first, middle, last. V equal Ri, Q equals CV, correct? Therefore, guys, what is C? Is it not Q over V? Correct? Now, these two, if we multiply them, because we want to find RC, if we say, okay, voltage divided by I times Q over V. Oh, this V with this V cancel, so the answer becomes what? Q over I. Now, who knows what is Q over I? What is Q over I, guys? Remember chapter 26, the first equation. What was definition of I? Electric current. It's Q divided by what? Time. Therefore, guys, Q is equal with what? IT. Current times time. Therefore, Q over I becomes what? Time. Therefore, what is Q over I? There you go. Time. What is the unit of time? Second. Correct? We solved it together. So what is the unit of RC? It's the second. So why do we call it time constant? Because the unit of RC is second, and we show it by tau. Make sense? Okay. So what we learned? We learned about charging of capacitor. I showed it to you in the class time, guys. For example, this is my camera on my phone. When I push the button, it takes, like, for example, let's say 2 seconds later, the light comes out. When light comes out, it's discharging. But that 2 seconds, for example, that 2 seconds, yes, it takes the time to charge that capacitor. So that 2 seconds takes time to charge capacitor. In defibrillator, for example, when the person, he or she got heart attack, we use those plates, correct? So those plates are like capacitor, and body is like resistor, okay? So it takes like 1 to 2 seconds, we charge them, then when we discharge, the person gets shock, correct? And you see the shock moves the person up, it gives the shock. That's discharging. But what we do before, we charge capacitor. So without charging capacitor, of course we cannot have discharging. If I don't have the battery in my phone or in the cameras, you cannot get flashlight because you need to charge capacitor, then discharge it inside that consumer, which it is light bulb. Now let's see what is discharging of capacitor. So at this time, I am going to write discharging of capacitor. So we discharge capacitor inside that light bulb. So here we have this: if we shift or we move switch S to position what, guys? B from A, okay? Now here what I have, look, we close switch S, correct? So we charge capacitor, then we move it to position B. When we move it to position B, this will be my circuit. Look, this is capacitor, this is resistor, am I right? That's all. So here, of course, I have a battery. So position B was here actually, correct? And this is Vmax. Now capacitor is not connected to the battery anymore. Capacitor is fully charged. So this fully charged capacitor acts like a very strong battery that it will be discharged very quickly, very fast inside this resistor. So what I have now, I'm going to write again. Let me start it from here. I'm sorry. So let me start to do equation. So using Kirchhoff's rules of voltage, which it says total voltage is 0. Therefore, I can have how many components, how many pieces, electric pieces do I have? One is capacitor, one is resistor. Battery is not in the circuit anymore here, correct? So this is my closed circuit. So I am going to have voltage of capacitor plus voltage of resistor is equal with 0. Voltage of capacitor plus voltage of resistor is equal with 0. Okay. And we know voltage of capacitor is, what is the voltage of capacitor using equation Q equals CV? So we will get what? V is Q over C. Okay. And we know that, yeah, using Ohm's law. What is the voltage of resistor using Ohm's law? We know VR is equal with R I. Am I right? This is V. So now here, and also these, we can put instead of voltage of capacitor, we do have Q over C. Watch, guys. At this time, I don't put minus here. Watch. What is differences in charging of capacitor? In charging of capacitor, here instead of voltage of capacitor, I put minus Q over C. Why? Because when we charge capacitor, capacitor consumes energy, so it's negative. But when it is discharging, capacitor acts like very high voltage, for example, battery, not high voltage, but very strong battery. So it's not consumer anymore. That's why I'm not going to put this negative here. I hope you got this. So when we discharge capacitor, capacitor is not consumer. In reality, capacitor is like source of power. Okay? Then this capacitor discharges in the resistor. So what is resistor? Resistor eats energy. So it will be minus R I equal 0. Did you get this? Now, oh my goodness. So what I have at this time, I am going to have this. Watch, guys. We know that Q is equal what? Oh, sorry. We know that I is equal with dq over dt, correct? Now, is dq over dt with its charge produced by capacitor by elapsing time, is dq by elapsing time, is q, sorry, let's say q, is charge on capacitor by elapsing time decreases or increases? What is your answer? So one more time. This is fully charged capacitor, then electric current, then electrons, they flow. So charge on capacitor decreases or increases after 2 seconds, after 3 seconds, after 5 seconds, after 20 seconds. Is it decrease or increases? What is your answer? I will say decreases. Why? Because of this, look, I can say, for example, let me write here, this is my scratch paper. Now it's 20 coulombs. After 1 second, it's 15. After another second is like 8. See, even it's not linear. After 1 second is like 2. So what is happening? Decreases. 15 minus 20, 8 minus 15, 8 minus 2. So delta Q for example, is 15 minus 20. It's negative 5, correct? So it is negative. Why? Because charge decreases. Remember, this is very important, because charge decreases. All right. So let me erase this. Now I'm going to use different colors, this one and this one. So if I use these two guys, I can have Q over C minus R is R. Instead of I'm going to put negative dq over dt equals 0, correct? Therefore, I can say Q over C plus R dq over dt equals 0, correct? So what I am going to have at this time, I can write Q over C is equal negative R dq over dt. So far good? Sorry about this. This is ugly Q. Let me write much better Q. Red one. Oh, okay. Correct? So let's see what can we do. This is again differential equation. I can write this equation actually like this. Watch it. dq over q is equal with negative 1 over rc dt. What do you think? Because in differential equation, actually, I have to move the same quantities on one side as much as I can, then the rest another side, correct? So here I moved q down, so it will be dq over q. You can do just cross multiplication. Anyway, I can get this equation. Watch, dq over q equal negative 1 over rc times dt. Yes. Okay, this is differential equation. Let me go by black color actually. So what I have, I can take the integral dq over q is equal negative 1 over rc integral dt, correct? Therefore, guys, I am charging capacitor, so integral dq is charging, sorry, integral dq over q will be what? ln q. Yes. So this was, I am discharging, so I started from Q naught, which it is Q max, to Q, so that will be from Q naught to Q, so ln from Q naught to Q equal, so this time will be from 0 to what? T, correct? So that will be minus 1 over RC T. Therefore, ln Q will be ln q minus ln q naught equal negative t over rc. Yes, then I can keep going. I can write this one ln q over q naught is equal with negative t over rc, correct? Then I can write q over q naught is equal with e to the power of what? Negative t over rc. Now if I do cross multiplication, I am going to have this equation. This one. Q is equal, but it is function of time, qt equal q naught e to the power of negative t over what? rc. Which qt is q max, okay? Sorry, q naught is same as q max. Oh, okay. If I solve it, if I do Vt becomes what? Vmax e to the negative t over rc. If I do for current, It becomes what? Imax e to the negative t over rc. Q max is CV max. Q is same as CV, and time constant tau is equal what? RC. These are all equations in discharging of capacitor. When we discharge capacitor, voltage versus time, guys, it's not linear. Look, we discharge it from Vmax and then goes very quickly exponential by time, but never reach to zero. That's why we do have capacitors in the lab. They are 10 years, 20 years ago. When we measure the voltage, when we measure the voltage of that capacitor, after 20 years, it's not zero. Why? Because this blue graph will never touch the time because of exponential equations. So, same way we have for Q over time. It's again like this. So it starts from Q max and goes to a very small amount. How is for charging of capacitor? Charging of capacitor, this is your graph. Pay attention. Voltage versus time. So starts from zero, then charge, it reaches to what? Maximum. This also will never be maximum again, but it's almost same as the voltage of battery. Even for Q versus time, we do have same thing. So this is Q max. Okay. Now let's do one example. So example can be this. It says in RC circuit, so let me write it. In RC circuit, okay, resistance is 10 mega ohm. Resistance is 10 mega ohm and capacitance is 4 point, let's say we have like this in the lab, so I go with lab 4.6 microfarad. It is connected, let's me write, it is charged with 30 volt power supply or battery, let's say, okay? So what is happening? Capacitor discharges into resistor. Find let's do one by one, huh? Part A. It says find voltage of capacitor. Ten seconds after switch. 10 seconds after switch S. 10 seconds after switch S gets open. Find voltage of capacitor 10 seconds after switch S, shifts to position B in the picture. So anyway, your picture is this, your graph will be this, C, R. So you have fully charged capacitor, which is with 30 volt. Now it gets discharged. Okay. So first of all, guys, you have to verify, is this question about charging or discharging capacitor? It says in RC circuit resistance is 10, okay, 10 mega ohm, which it is 10 times 10 to 6 ohm. Capacitance is, so C is 4.6 microfarad. which is 4.6 times 10 to negative 6 farad, right? It is charged with 30-volt battery, so your maximum voltage of this battery or maximum voltage of capacitor is 30 volt, correct? Then it says capacitor discharge into resistor. Find voltage of capacitor 10 seconds after discharging, you know? So find voltage of capacitor when at t equal 10 seconds. Make sense? Okay. So what I'm going to do, guys, they want me to find voltage. So what is the equation of discharging of capacitor for voltage? This one is. The second one. Oh, Vt is V max E negative T over RC. Okay. So let me write by red color, huh? Some of you like also red color. So I'm going to use this equation. Vt is V max E to negative T over what? RC. Correct? I suggest you always in these kind of problems, if you can, if you do have all data, find tau, which is RC, okay? So then it will be easy, you know? So you don't need to write here this times that. No, just do the answer. So in reality, this RC is tau. So R is 10 to the power of 7 times C is 4.6 times 10 to negative 6, correct? So if you do that, tau will be 4.6 times 10, so will be 46 seconds, correct? Therefore, guys, substituted, let's use now that equation. So they want me to find voltage after 10 seconds. Okay. So voltage at T, you know, let me, oops, what is that? It's here. Let me say V at T equal what? 10 second. There you go. Equal V max. Instead of V max, I'm going to substitute 30. E to the negative. This E, it's not charge of electron, remember. It's natural log number. So E to the power of negative T. What is T, guys? What is T? 10. And what is RC? 46. Everybody go ahead, go calculate this number, please. Use your calculator. T voltage after 10 seconds. Where is my calculator? Where's my calculator? Oh, it's here. Go ahead, find the answer. Everybody, please. To the power of 6. I got 24.13. Did you get same answer? So this is the voltage of capacitor 10 seconds later. So this is part 1. Let's see what it says part B. Part B. It says, how long does take? How long does take? To capacitor, how long does, let's find time, huh? To capacitor to reach oops 10-volt voltage. You know what does that mean? That means this is how many seconds later the voltage of capacitor is 10 volt. Okay. Again, I'm going to use this equation. Vt is equal what? V max e to the negative t over RC. But at this time, your unknown is time. Watch it. So Vt is 10. Vmax was how much, guys? 30. E negative t. It's all algebra. RC. What is RC? We found it, right? It was 46. RC is 46 here, yes? Oh, it's gone. RC is 46. Now use your calculator. This will be 1 over 3 equal e to the power of negative t over 46. Everybody go ahead, solve it for time. Let's see what is time. So let me show you what I am going to do. Maybe some students, they want to see how we derive this. Look, guys, what you need to do, you have to take a natural log. ln 1 over 3 is equal with ln e to the power of negative t over 46, correct? Now, if you do that, you know also this one. ln e to the power of u, the answer is u. So we will use this. And let me find ln 1 over 3. Ln parenthesis 1 divided by 3 parenthesis close. Answer is negative 1.09. It has to be negative, be careful. 1.09 equal negative t over 46. So here e to the power of negative ln t to the power of u will be u, that. Therefore, time becomes equal with what? 46 times 1.09. The answer is 50.14. Correct. All right. So 50.14 seconds after we shift switch S to position B, after discharging, 50 seconds later, the voltage of capacitor reached from 30 to 10. Let's see, what is this? Part C, it says this. What is charge on capacitor after 10 seconds? Okay. What is charge on capacitor after 10 seconds? There you go, I'm here. I lost myself. Okay. You know, you have to find Q. Let me see, what is wrong? Why this doesn't let me? Okay, Q equal, what's wrong with this? Q equal, question mark. You know this equation. Q equal what? CV. You want to find charge after 10 seconds. You already have voltage after 10 seconds. You already have voltage after 10 seconds. I'm sorry. What is the charge on capacitor after 10 seconds? Okay, let's do that one. All right, let me see how this works. I don't know. I'll figure out it later. So we have to use what is charge on capacitor after 10 seconds. We have to use QT is equal Q max, correct? E to negative T over RC. Therefore, and we know that Q max is equal what? CV max, am I right? So I'm gonna write this Q T equal 10 seconds. Q max is C. C is 4.6 times 10 to negative 6. V is 30. And then here E to the power of negative 10. RC, how much was RC? 46. 46, yeah. Now if you do this number, charge after 10 seconds, okay, I'll figure out what is happening. My draw, it doesn't work, my symbol. So let me finish this. 4.6 times 30 times, let me open parenthesis, e to the power of negative 10 divided by 46. Then that number times 10 to negative 6. The answer will be 1.11 times 10 to negative 4. 1.11 times 10 to negative 4 coulombs. This is charge on capacitor. Okay, what's wrong with this? Yes. All right. Okay. Now, guys, I want to give you one example. What is wrong? Okay. Doesn't work. My page doesn't work. Seems my computer hanged. Yes. All right, so what you have to do no, completely stop. My screen doesn't work. All right, so we're in good position. We're done with majority section of chapter 27. So what you have to do, guys, I want you to go over from your chapter 27, part 27.9. It's about RC circuit. I want you to do problems number 58 and 61 as quiz number 6. What's wrong? What's that? I don't know. I have to restart my computer. Okay. So as quiz number 6, do is zero 03 27 20 until 11:59 p.m. So problem number 5861. Solve them. Do not copy from Google or solution manuals because I will know what way are you going. So watch the video carefully and answer it, please. Okay. I love you guys. Everybody, please study, watch the video, and if you have any questions, please let me know. Have a very good day and also good weekend, okay? So on next week, during our class time, we will go over problems by Zoom. Have a very good day and good weekend. Email me, please, if you have any questions. Bye, guys.